Dr. Chuck the Science Schmuck.
Synchronize. So about that banana. Yeah, there's a bit of a problem. This is my banana. What happened to my poor banana? It's dry, but at the same time decaying. Because of an unfortunate oversight. Not exactly an oversight, but a consideration I hadn't made. Now, the mummification process in ancient Egypt and in elsewhere consists of drying, primarily, and adding preservatives to keep the flesh maintained. But dry is the solution. Really, it's ultimately the dryness of an area that preserves the mummy. If a mummy is taken out of their native dryness, Egyptian mummies are in nice, dry Egyptian tombs, buried way out in the desert. If they're ever exposed to moisture, they'll start decaying again. It's not that the process of mummification necessarily preserves them absolutely. In this case, the banana was stored over there, sitting in my basement, for about a year, actually, in basement conditions, which you'd think the sheer amount of radon down here would preserve it, but radon doesn't do that. In actuality, it's wet. Really, really Met. Really, really moist. Constantly moist. Damp, even. That caused fungal growth, decomposition, eaten by bugs, anything. So the banana is not in good condition. And actually, this isn't unprecedented in the process of mummification. You have to consider, Egyptians had a good mummification process, but nobody really checked on it. That we know of. A lot of that record of how they developed the process is lost, but they'd wrap a guy up, put him in the sarcophagus, put him in the tomb, and he'd just sort of be there forever. Ideally forever, never opened again. They didn't know if it worked necessarily. They kind of understood that it did, but sometimes it didn't. In fact, King Tutankhamun, if you've ever seen a picture of what he looks like, although his tomb was found in impeccable condition to the point that they say when they opened it, there were flowers that had been there for 3,000 years that just decomposed instantly when the wind hit them. King Tut himself didn't mummify well. It's kind of a failed mummification. He looks kind of like a skeleton with a face. In that case, it's not because of moisture exactly, but because when they applied the mummification, they applied too much oil and too much sort of mummy sauce, and it resulted in him decomposing inside the sarcophagus to the point where he's not as well preserved as you would expect for a mummy. This banana, unfortunately, had the same situation. So either I hear the inside of my brain squeaking or I hear birds. There can't be birds. It's like -4 degrees outside. It's actually quite cold in here. Which will help with the next process, is that I need to build the banana or sarcophagus. And not a sarcophagus in the sense of a mummy head, which was basically a big box inside a box inside a box inside a big pyramid. Not necessarily a pyramid. A lot of kings in Egypt were buried in much less pointy tombs. I need to build this, a special thing that the Egyptians didn't build, because I didn't make this banana to survive a year or a month. A month is longer than a year, right? I don't know. I want this banana to survive eternally, and I think there's still enough of it here to survive that process. I am going to fully fossilize the banana by encasing it in concrete. And how am I going to go about doing that? Well, with concrete, as you would expect, but it's more complicated than that. The first thing to consider is that right now, the banana is not suited to concrete preservation. It's actually very dry. Oh, it's a good thing I can't remember what I did to that banana before, because that would be real gross if I knew. Why does my tongue burn? It tastes really salty, which means the process is sort of working. Also a problem, using calcium chloride in your salt. Calcium chloride is hygroscopic. It pulls water in. So the first thing to do is I need to make the banana waterlogged again to undo the drying process. That way the banana will sink in the concrete, because if you put it in right now, it'll just float to the top, and then it won't stay in the middle for the rest of eternity. What is this? Calcium carbonate. Specifically, crushed eggshells. As part of my new diet plan, I've been eating a lot more eggs and a lot less pasta. and I get a lot of these shells. So I bake the shells to kind of destroy protein and get powdered calcium carbonate. So that's the first thing I'm going to do, is soak the banana in calcium carbonate, or more specifically, calcium acetate. We covered this before. I'm using up the rest of my vinegar that I bought new vinegar. Vinegar is acetic acid. When exposed to calcium carbonate, it strips the calcium away and forms it strips the hydrogen away. It strips the hydrogen from the acetate, combines that with the carbonate. That forms carbon dioxide, which leaves the solution, and leaves behind calcium acetate. Calcium acetate is ultimately what we want the banana to possess. Why does that smell like that? Oh! Oh. Okay. Well, that's pretty intense. And you can see it is rapidly decomposing the eggshells and producing gas. That gas being the carbon dioxide. So I will let that brew, and once it stops doing that, it means the solution is now mostly calcium acetate. I'll put the banana in there and let it waterlog until it sinks. That way it will be prepared for the ultimate concretization process. Do note, when you're doing this, lid on loosely. If you tighten that, you're building up gas pressure, and it will explode. Glass and eggshells and vinegar. Well, this should be immediately apparent. The banana has sunk, which means it has absorbed a significant amount of this solution. What is this solution? Well, considering that there's a significant amount of undissolved eggshell layer at the bottom, that's probably calcium acetate. Why is it brown? That's a combination of banana and this brown stuff at the bottom, which you may notice. That is because the eggs were cooked before use, in that I put them in my oven and cooked them until they were black. And that is the dissolved protein. Well, not dissolved, it's the carbonized protein. But a thought occurred to me. I realized that even though the banana is stored in this acetate solution, it may still decompose inside the concrete. And I should give it a secondary treatment to put antimicrobial... Is that a bug? The microbes are already coming to get me. I should put an antimicrobial aspect into the banana. I intend to do that with 1, copper carbonate, which I made previously. Very powerful against insects, very toxic to just about everything. And 2, borax. I've had this for years. Oh, it smells like, I don't know, someone else's house. That's probably where I got it. Sodium borate, which is both a preservative, an antifungal, and toxic to insects. I don't expect insects in the concrete, but I don't want there to be bacterial or fungal decomposition in there. So what I'm going to do is, firstly, smell the banana. Taste the banana. Doesn't taste as bad as you would think, but it tastes more burning than you would think. That right there is the banana. It's assumed this interesting black color. My fingers are wet with very gross things. So I'm going to take 1 spoon and into this. That smells pleasantly clean. A flattish spoon of copper carbonate. And then 3 big spoons of boraxo. It's actually just borax. There's no O. Solution has now become green in color. and it is a combination of calcium acetate, random banana juices, borax, and basic copper carbonate. It's now a preservative media with which I shall preserve the banana. I have noticed the banana has a hollow area in it, so it's best if it goes in this direction. I don't know where the rest of this will have to... I'll see if it dissolves. I might only get half a banana by the time this is over. And then I need to allow that to sit, because today's Wednesday. I don't usually film on Wednesdays. I need to let that sit for the weekend to absorb preservative so that it'll be ready for its eventual inhumation in what will become its fossil grave. There's an echo in here, and I don't know how to feel about that. But the time has finally come. The banana is percolated, and it's time to bid it adieu from this world and put it into its eternal concrete slumber. The first step being, I have to get all parts of the banana out of that liquid, which I'm no longer 100% sure what this liquid is, because it did form what looks like precipitate. That's part of the end. The end has disintegrated, because bananas are not a very durable fruit. That kind of doesn't feel good. Let me wash that. Who knows what that's made of? I sure don't. There is a possibility that mixing calcium acetate with borax does weird things to the boron and like cross-links it to the acetate or makes calcium borate. I don't know what that is entirely, but it's good enough. The banana should be well preserved. Now, I've made this cast. It's not fully a sarcophagus because this is just a mold. It's wood that I found in the wood pile, hot glued together, so I can snap it apart pretty easily, or cook it in the oven until it melts and falls apart, and get the banana out. I'll be using my normal standby of sifted concrete. Yes, I know that's just cement with a little bit of fine sand in it. I can't afford cement with fine sand. It's like $2 more. I don't know why I have these spoons. But I guess that's how I'll be adding the concrete. Ugh, breathing it, getting silicosis of the lungs, which is actually a very severe condition you should avoid having. Okay, I got some of that. I've got some water. Warm water. Probably shouldn't be warm for concrete, although the temperature in here is excellent for concrete formation. That's why I'm doing it now. It's probably about 40 to 50 degrees in the basement, which is just around the temperature that you want to have concrete at. No, I got wet, but that's not unusual for me. I was wet before I even started. Using the stick to massage the concrete to intercalate the water into its structure. Now this is unmodified concrete. I don't know if anyone who watches this channel watches all the way back to the original, but that cube that's sitting on the corner of my desk that you may not be able to see, that is always here for some reason, is made of carbonized concrete, which is it's concrete that has carbon and other ingredients in it that are then pyrolyzed later. The difference also being, there is an improvement, because this is basically just a modified version of this cube with a banana in the middle, but with an improvement. That is raw concrete. Raw concrete has aggregate, which is little rocks, which disrupted the way that the cube formed, although do give it greater thermal resistance when I'm lighting fires on top of it, because normally concrete explodes when you heat it. Now I've made this relatively soupy material. This frame is sitting on top of plastic wrap on some flat styrofoam just to give me a surface that should stay flat-ish. However, it's not actually jointed to the plastic, so any extra water will just flow out between the two. So at this point, what I'm doing is, it's probably hard to see, I have a secondary camera in my pocket that I will deploy in a moment when I actually apply the Bananer. And at the moment, I'm just getting the lower layer set, so that it covers the entirety from wall to wall, all the way up the mold, in everything. So that's a very moist intermediate layer. the banana. I'm going to fill the banana's crevices with water. And then lay it down with its little broken end next to it. And as I said, camera. Cell phone. I have 2 cell phones, like most millennials. Interestingly, the cell phone takes much better video than you would expect to see in an ordinary camera. But, as you can see, the banana has been inserted into its grave, like a banana is a botanical berry, so this is like the berry form of Jimmy Hoffa. And it is stuck into its final resting place, so that we may see it off to eternity. As you can see, it's not doing anything. It's a banana getting encased in concrete. Did the video stop? It stopped. I am also going to photograph this for the thumbnail, because once this is done, no one will ever see this banana again. It will be gone forever, except preserved forever. Although technically speaking, it is possible to see the banana again if you were to remove the concrete. The banana is not acid soluble, but the concrete is. I mean, if you really wanted to get it out, you could just immerse the concrete in a lot of acid and dissolve your way to the banana. However, that may only work for the next 100 years or so, depending on how I treat this. An interesting factor about concrete, it's basically like, it is the equivalent of human-made limestone, because that's actually what it is. That's how you make cement, is you take limestone, which is calcium carbonate, you cook it to turn it into calcium oxide, and that's the key ingredient in cement. If you've ever been in a cave, and I've been in a lot of them, that's a family thing in the Schmuck family, is that whenever we go somewhere, we find a cave and try to get as deep as we can. Not like professional cave divers, not that exciting. We go on tours in caves for like an hour walkthrough. It's super cool, because we're all basically either Morlocks right now or evolving toward Morlockism. But caves often exist in limestone areas where a flow of water has eroded its way through the limestone and made a channel. Caves develop stalactites and stalagmites and flowstones and all that stuff because water percolates through the limestone in the ceiling over time, and water's slightly acidic most of the time because carbon dioxide dissolves in it, and it dissolves a little bit of limestone, comes out, drip, 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 and over time that forms a stalactite. Concrete does the same thing, but exponentially faster. Now, why do I say that? Because there's a possibility, and I can't demonstrate this because it would take millions of years, that exposing the banana to concrete, if this gets wet over time, will cause calcium carbonate to precipitate out of the concrete and into the banana. I'm covering the banana right now. Causing the banana to develop accumulated calcium carbonate and consequently solidify, much in the way that you would see like petrified wood, which is what I was originally attempting to do. But this will do it much more efficiently over a much longer period, which is the very definition of efficiency, is doing the same thing, but less efficiently. Now, the banana does not appear to be floating at the moment, but that's a hard thing to assess. Concrete is obviously denser than a banana. It's also much more viscous than a banana. So it's a question of, will the banana eventually float up through the concrete, or will it stay where it is, being forced down by the weight of concrete on top of it? Oh, what do I look like? Some sort of scientist? How many scientists do you know wear stolen lab coats and Hawaiian shirts? The Hawaiian shirt is probably not stolen. I don't know, because I don't really know where it came from. Like, that's a thing when you have Hawaiian shirts. You can't really remember where they came from. They just sort of show up. I'm going to additionally pack the concrete. I don't really need to hammer it. It's not hard enough to warrant hammering. This is a wider stick, if you didn't notice. That was also in my basement wood pile. Because who doesn't have a pile of random sticks in their basement these days? So that hopefully will keep the banana contained by the time the bottom layer starts to harden. It also will slowly degas itself, which means there's air in there, obviously, because I'm not working in a vacuum. It'd be nice to be able to cast concrete in a vacuum, but I don't have a vacuum. And I don't mean I mean evacuating the air from a room so that I'm working at zero pressure and the concrete can be super dense. It is, in fact, quite wet and gooey, and slowly releasing air. That is way more wet than concrete should be for a structural application. So if your concrete looks like this and you're trying to build a sidewalk or a building, that's a problem, and you're not good at your job. But then again, neither am I. And I suppose this begs the question then, how long does it take before this is done? That's back to the scientifically interesting thing. I almost had an urge to drink that. Not that, that's fine. That's borax and liquids. The hardening of concrete is a complicated subject in that this will probably be hard enough to remove from the mold within 4 days to a week. But concrete continues to harden over time, so it may take up to a month, which will vary once I open it up and see if it actually hardened to quality or if it's all crumbly, which it shouldn't be crumbly. It should be banana. So we'll wait, but other than that, that banana is now entombed. It's gone for good. It's in there, if it hardens, solidly for the rest of forever. But I have to go through time in real time, so I'm going to be spending a long time waiting for this to harden. You're going to flash to it instantaneously. Concrete! The mold worked. I mean, better than I thought it did. There's actually a degree of automation I wasn't expecting. As the concrete solidified, it basically ruptured the glue on the mold, and this thing came out months ago. Months? There's no one actually there. Months, years, I don't know. Actually, it's probably been about 2 to 3 weeks since the banana was fully entombed in this block of concrete. However, this is a block of concrete. Concrete is not, in fact, eternal. It lasts a long time, but I mean, come on. Have you ever seen a concrete building from, like, I don't know, 50,000 years ago? No, because all that concrete decayed. It fell apart. I'd like to preserve this further. That would involve, firstly, I'm going to have to sand it down. I mean, look, the edges are a little rough. I'd like to get it smooth. Palm sander, that'll handle that. But I also want to... take care of other aspects, namely the fact that this is basically a sponge with a banana inside it. Concrete is not, in fact, solid. It's porous. It's made of tiny holes, which are a combination of just air bubbles and inherently concrete structure. It's heavy, but it's also full of a lot of water. The banana exists in here, inside this block, but it is still wet, and it is still organic. Conceivably, it can decay. Probably not, because I soaked it in preservatives, and over time, water leaching through this would eventually solidify this into a solid calcium carbonate block, but calcium carbonate as a rock is not actually that stable. I mean, limestone is, but like dripstone, which is what you get when you have like caves, limestone, water falls through, creates crystals of stalactites and stuff. That actually happens if you draw water through concrete too, but that's not the point. The point is I want to varnish this, but first I need to purge the water. And that's a little bit difficult in that now we're starting to go into the territory of stuff you never want to actually do to real concrete. In that I want to bake this. Normally concrete is not used like this. It's used to make buildings, like the wall behind me. That was made probably about, 50, 70 years ago. This house is super old. You don't normally cook a building. I mean, you could. It'd be hard, and it's not necessary for concrete to work. Over time, the concrete eventually just sort of fuses into a way where it's stable. it breathes. Since it's porous, the water can escape over time. But if I'm going to seal the concrete with something, like this wall was sealed with paint back in the 50s, I want to purge as much water as possible. And the way to do that is with heat. But that's where the issue is, in that concrete can't survive heating. In fact, if concrete is involved in a fire, it's ruined. If a building that is made of concrete is on fire, the concrete it's done. Even if it's still standing, that concrete is ruined. The building has to be demolished. Why? Because concrete is a composite material made of multiple different chemical structures. Like a diagram. This doesn't make any sense to you right now, but it will hopefully make sense by the time I'm done explaining it, and by the time the coffee really starts kicking in, which I just drank a bunch of it before coming down here. So the concrete originally is an aqueous sort of gel. It solidifies into various calcium-based substances, but it also has inherently silica. So that's, in this case, fine sand. This is sifted concrete, but it would also be aggregates like rocks, which can be variable in what they're actually made of, but think of it as rock. Silica as rock. It could be glass. In some cases, they use depleted uranium. It makes very heavy radiation-resistant concrete. I can't afford depleted uranium. That's just incredibly expensive. So this is just full of cement and sand, which is kind of the issue here, is that part of this is these hydroxide groups. It just sort of exists in the nature of concrete, which is actually much more complicated than calcium hydroxide. There may be some in there. But essentially think of it as a water-bearing calcium species. So there's free water, which is just water that's just associated with the crystal structure, as well as water that's associated with calcium as part of the chemical structure. When you heat concrete, it produces an issue in that most substances, when you heat them, expand, but not if it's off-gassing. So it spits out, this water that's inhabiting the porous structure first, that exits as water vapor, which is fine. That doesn't really damage the concrete too much. The concrete can be totally dry and still function, I think. But the calcium-bearing species, if you heat it up further, about maybe 600 to 700 degrees, they start spitting off these hydroxide groups that are part of the crystal structure, and that leaves as water too. What that does is it takes this species and shrinks it. The concrete begins to compress or shrink on itself. But there's also aggregate, in this case silicon oxide or sand. That behaves like a rock does. Rocks don't shrink when you heat them, they grow slightly. Not visibly, but appreciably when you're in a constrained space surrounded by solid. If a rock expands, it puts pressure on its surroundings. So you have part of the concrete, the matrix that's holding in the silica, shrinking, and the silica is growing. If you hit a certain temperature, that produces so much internal stress into concrete that the concrete is going to break. Not shatter exactly, but its structural integrity is completely ruined. That's why, as I said, if a fire, which is very hot, many thousands of degrees, is in a building that's made of concrete, the concrete undergoes that and the concrete loses structural integrity. It can no longer support the building. So I need to heat this hot enough to remove most of its water, but not so hot that it actually ruptures the concrete or puts it under any special stress, which not the hugest issue here because this isn't load-bearing, ideally, although it may eventually be incorporated in some post-modern, post-civilization, Postmodern is like a weird art form that people, oddly enough, like 60 years ago did. Postmodernism follows modernism, which was in the 20s, and therefore it's super old. It might be building material in a castle after civilization falls, not knowing there's a banana inside, but I'd like to have it preserved durably, and to do that I'm going to heat it to about 500 degrees in my oven for quite a while to evaporate out as much water as I can, and in the process I'll also be generating the varnish. But before that, sanding. Okay, now's the part where things get dangerous, and therefore interesting. While the concrete is upstairs baking, removing its moisture, I need to prepare a varnish. And what's that you say? Can't you get varnish anywhere? Why yes I can, but I'm not going to. I'm going to make it, because I like mixing chemicals in my basement and breathing the fumes. I actually only like mixing the chemicals. Breathing the fumes is kind of pointless for me. So, for this it'll require a crucible, in which this case is a large can that formerly contained pasta sauce. In this case, you're going to want the can not to have any pasta sauce. Also, you'll remove the liner. I did that by baking the can at 500 degrees until the liner just disintegrated. That goes there. Maybe I shouldn't turn it on quite yet. I don't want to have this explode in my face. So the primary ingredient in the varnish I want to use is boiled linseed oil. This has been discussed previously, I think, in my attempt to make artificial amber, which this is actually a derivative of. I tried to make artificial amber. I'm going to make that, but as the varnish for my concrete block. The idea being to seal it with a slowly polymerizing organic surface to keep out moisture and keep the moisture in relatively controlled, and to permeate the concrete to keep it stable. In order to do that, the basic ingredient is boiled linseed oil, which is flax oil. It's just an edible, it's not really edible, oil, which has been combined with a catalyst such that it goes rancid very quickly. You can kind of tell on the top here, as boiled linseed oil goes rancid due to exposure to oxygen, it polymerizes into a plastic-like substance. When added to other ingredients, that allows it to form potentially a very durable varnish, an almost amber-like substance. Not actually in this case, because for that we'll use the gum rosin, which will be an ingredient added into it, which that, over millennia, can polymerize into amber. In this case, we're going to start... the linseed oil has gotten a little old and gooey, so right now it's a lot yellower than it formerly was. So I kind of need to use up the bottle. Ooh, goopy. Now, one thing to potentially note is that all of this is very, 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 very flammable. So, keep that sealed and refrigerated when not in use. Now I'm going to turn on the heat. Hopefully this doesn't explode on me. That's why I've got the lab coat sealed. That's going to need to heat up and get warm. It's a little bit like, I'll compare it as an analogy, and move over here so that if it spills, I can dodge. It's a little bit like preparing a fryer. You've ever fried or deep fried food in a pan. You get a pot, you fill it up with oil, you heat it up to a temperature that's quite high. The boiling temperature of any edible oil, which this is technically derived from edible oil, is high. So don't touch it. It's going to get up to like 300 to 400 degrees Fahrenheit. Oh boy, that's not a good sound. Okay, I'll be back in a second. So, because I don't want to boil myself to death in oil, I've gone up a safety grade. As you can see, face mask. May distort my voice a little, but it keeps my face from getting melted off. Not just my eyes. Also, thermally resistant plastic gloves. And a stick to stir. So the boiling, that hissing sound, is probably a result of the water that was in the can when I washed it out boiling away as the temperature exceeds. Now this substance is gum rosin. It looks like crystals, but it's actually a derivative of pine sap. That'll add some gooiness to it. Ideally, that'll get melted down and dissolved into the boiled linseed oil, which does not make a great amber substitute, as we've proven previously, because it gets too soft. Well, there's some other substances I'm curious to add. One is polystyrene, styrofoam. I mean, it should dissolve, and it may assist with the polymerization a little. See what happens when I dip it in there. It begins to melt and dissolve. That's because the oil is both a solvent capable of dissolving polystyrene and hot enough to melt it. Polystyrene isn't normally recycled, so rather than let these pieces end up in a landfill, I say, why not add them in? Let them break down and dissolve and be useful for preserving this. Now, polystyrene does sometimes occur as plastic. That's what red Solo cups are made out of. So it's not exactly the most moisture protective, but it'll help add a different polymer group to the structure and allow me to recycle some of this rather than throwing it all away. Give some bulk to the solution. So this clear type is the stuff that is what soda bottles are made out of, which is plastic number 2. I'll have to put in the description what that abbreviates as. I don't remember what 2 is. No, 1. It's 1. 2 is polyethylene, so we'll get to that in a second. I'm starting to smell this stuff. It smells like rosin. This stuff does curl up and dissolve poorly, but it may melt, so I'm going to send pieces of that into the bottom there. I've additionally got these, which are fragments of a milk jug. Milk jugs are made of polyethylene. Polyethylene is a long hydrocarbon chain of just carbon, 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 hydrogen. It's what Vaseline is, but longer, that turns into paraffin. Longer turns into polyethylene. Longer turns into ultra-high molecular weight polyethylene, which is expensive and probably wouldn't really dissolve in this circumstance. This may not even dissolve, and it's not so much dissolution as it is, well, it's melting and then using the linseed oil as a solvent to dissolve it into a material that can then be applied elsewhere. You can see it does turn clear and start to melt, so I'll just drop some of that in. If it doesn't dissolve, it's just going to stay at the bottom of the can. I'm not going to reuse the can for anything. The other is this. It's a piece of a plastic bag. Don't know what it's made of. It's going in there. Oop, wear the glove for that. That one gets a little hissy. Probably because it's a little wet. That's making me nervous. That's making me real nervous. Quick, the stick! The problem in this case, that reaction is because a lot of this was materials that I recycled. I chopped them up, but I had to rinse them out first. Water on contact with oil immediately dissolves and boils. Or it doesn't dissolve, but it immediately boils at these temperatures. So this right here is the banana in block form, heated to 500 degrees Fahrenheit. I don't know how this is going to do or what this is going to do. Might explode, might burn, might spill everywhere. Gonna make sure I have a good grip on that. There's a little bit of residual water on my table and on my pliers, I guess. That's what's causing the hissing. Now, in theory, that does help to remove moisture from the concrete by boiling it out of existence. I should be able to handle the concrete with these gloves on. Although not for very long, it's very, very, very hot. The idea is for this oily, plasticky substance, should not be pouring toward me, to be absorbed by the porous concrete, and then later to polymerize and fill all of the concrete's holes. Looks like that's all the stuff I've got. Excuse me while I soak down myself. Well, actually, not quite yet. There is a consideration that needs to be considerized. One, that this is hot and should probably be away from the flammable oils. Two, is that boiled linseed oil is an extreme fire hazard for a second reason. In that, as it polymerizes slowly over the course of days, it's highly exothermic to the point where it can light itself on fire. Oil-soaked rags, soaked with linseed oil, have burned on a very large number of structures. As such, everything here that has touched linseed oil that is flammable, including this bag, including the paper towels I will use to wipe up the table, is a fire hazard. And it can't just be left somewhere. I will most likely sequester it in my oven until it has dried, because if you get a fire in your oven, it's a contained location that can handle heat. It'll just get absorbed. Either that or I'll put it outside in a snowbank, probably soak it all down with water. The key here would be not to allow it to be in any situation where it could catch on fire, and to continue to get this nice warm banana brick soaking. It is pretty obvious that it is absorbing moisture, which in this case is not moisture, it's not water. It's a mixture of, primarily, the things that dissolved in it are polystyrene, rosin, and of course the linseed oil itself. Sounds like it's boiling a little. So I'll keep an eye on that. Gloves and tools can be decontaminated with soap and water. So I'm going to clean up this giant, oddly tasty smelling mess, and we'll flash back to when this has fully finished its preparation and is ready to be displayed as a brick. And there you have it. Now, it's not immediately apparent to you the sheer amount of time that has gone between me doing whatever it is I did last time, I literally cannot remember, and having this complete, because I cannot film videos during the winter, because immediately behind you is a large furnace. And what does a furnace do? It ferns. So there's ferns everywhere. Actually, there is a fern over there that I found in somebody's trash pile. It's growing weirdly nicely, but it lives down here because of my persistent fear of bed bugs. Which actually probably would be interesting for this channel, which has been basically abandoned for 6 months because that's how long winter is here. Because I probably have to take dog medication to get rid of them. The banana is here, in this brick. The brick is concrete and has been sealed at least like the 6 months of time I've had it sitting on my kitchen counter has allowed it to cure somewhat, allowing the linseed oil to polymerize, making it nice and sealed. Now, theoretically, the banana could be rotting in there to an extent, but it's coated in borax and sealed in concrete in an environment where it doesn't really have good access to oxygen. Although concrete is porous, so there is airflow. This is like a molecular scale size sponge. And you can actually view, compared to my original cube, there have been improvements in the concrete making technology, although it's a completely different type of concrete. But that's the banana entombed and imprisoned forever in this block. I mean, unless you crack it open. Which then begs the question, will this banana be able to persist for the rest of eternity? No. Eternity is a very long time, and at a certain point, the half-life of protons causes all matter in the universe to eventually disintegrate into absolute nothingness. I read a list about it, listing every single thing that'll happen in the next 10 to the 136 power to the 300 something power. It's very depressing. Good thing I'm immortal, though, so at least I get to see all of it. But more realistically, how long do you think this banana could last? Well, assuming that this brick stays in my possession for potentially years, it'll be in a building, probably not damaged or lost in any way, and it'll be kept nice for at least that long. I don't know where it would go after that, if this will just be something that gets thrown out in the yard by my various descendants, or gets left behind, lost, if it gets used as building material by somebody building a shed or something, becomes part of some fill. I figure after a certain period, even if it gets passed down, it will end up outside in a trash pit somewhere. Exposed to the elements, I think it can probably survive in that environment, assuming it's not broken, for probably a few hundred years at least. So I think it would be reasonable to say that barring specific intervention to free the banana, that banana should be in there for at least the next 300 years. I don't think this thing will necessarily, I mean, it could be destroyed tomorrow, but I think it is reasonable that it could exist if it's kept indoors or buried in a foundation or something, or put in some fill or buried underwater. This block could exist that long. I don't expect it to go anywhere. It could easily continue to exist if the environment is right, if it's not too acidic, for another, easily 500 years. Could it exist long enough to fossilize? That I don't know. After that point, you start to say, well, maybe the concrete begins to break down. Who knows? For all I know, it'll end up in a very good situation. For example, being left in the basement of an abandoned building, or covered under relatively dry dirt, like if you buried this in a desert. And it could last literally thousands of years, but that's unlikely. It's interesting to know that I've created something that has the potential to preserve a banana for many times my own lifetime. Theoretically. Just in there, forever entombed, never to be seen again. Till someone cracks it open, I guess, but you'd hardly know there's a banana. I don't know if that's a positive thing. Very depressing. But that's the conclusion of the video, which has taken me about 6 months to make. Now, I have a list of other videos I need to go get through. I know nobody watches this channel, but at this point, I don't care. I got tired of not making these videos. It's fun for me, and I like doing it. So you don't need to really like or subscribe, because it doesn't actually matter in any appreciable way. I probably won't be doing these videos for that much longer, to be totally honest, but I'll continue to do them for as long as I want to. So, extra.